Let's see. So the first one, pay attention, guys. Put your cell phones away. With an example, when I say with an example, always use an example. Okay. Some of you have not used an example. So describe the poles. What are the poles?
Pose is the numerator, and you set that to 0.
Right. So poles are the roots of the
the roots.
Numerator of the transfer function. All right. So you have to describe. When I say describe, you have to with an example.
What was wrong with doing just
Yeah, I'm going to talk about it.
You just wanted what pose is.
Right. So if you do this, if this is your transfer function, if you've taken this as an example, let's say one sentence. Poles are the roots of the denominator of the transfer function, and s is equal to minus 2 is a pole, and s is equal to minus 4 is a pole. Okay, you have to indicate that.
Right? I mean, but if you say that, then I don't. I mean, I see where you're coming from. You just said example, though. It says describe the pose. I mean, I see what you're saying.
The second one, same example. You can say, what are zeros? Zeros are?
S plus 3 equals 0, or whatever you have at the top. Yeah, S plus 3 equals 0.
So if I say write in one sentence, how will you write it?
You would just say the roots and numerator of transfer function are called 0.
I want everybody to understand this. I think you understand. So why don't you stay quiet and let me ask others.
I'm just confused because I thought you wanted to.
You don't worry, Torius, you're done. Okay. You're done. You're much ahead, okay?
Yes, sir.
You don't need to worry. So there are others who need to worry. Okay? You're okay.
Yes, sir.
The same thing, right? You have to write one sentence. Describe what are zeros. They are?
Values that make the function equal to 0. And that's what I put, and that's what it looks at, and I was confused.
That is the characteristic of it. What are they? They are the roots of the poles are roots of the denominator of the transfer function. Zeros are roots of the numerator of the transfer function.
But that's like...
So what is the connection there? What are we connecting? We are connecting automatic controls and we are connecting mathematics. Does that make sense? This can be purely mathematics. Okay?
Yeah. Only reason why I never said...
Poles and zeros are what? Control terminologies.
Because like the only reason why I never put like fruits of the numerator is because the book only really talks about the denominator like it's important. Like the roots of...
Zeros are... You have to just write roots of the... See, the thing is, I gave you this exact sentence in your notes. If you recall, go back in your notes. I wrote this exact sentence. Zeros are roots of the numerator
of transfer function.
Numerator of the transfer function. And similarly, if you write poles, it will be
same thing itself as the
denominator. That's what they are. That's how you describe. And you have to just when you describe, these are poles and s is equal to minus 3. This is a 0. Okay. Characteristics. Poles are, this is what I was looking for. values of S which make the
System. Would this
the
here?
transfer function to be infinite, right? And zeros are values of S which make the transfer function to be 0. Alright. So try to understand this. This is the characteristics and it is very clearly mentioned in the textbook. Okay, you have to just highlight that. I've given you points even if you have said something else as well, but this is the main characteristic of a pole and a zero. Okay, so here, what value of S will make this infinite?
-2.
Right, if you substitute -2 in S, right,
0.
it will be, this will be 0. So it will be 1 over 0, which is infinite. If you substitute S equal to -4, it will be -1 over 0, which is infinite. Alright. What value of S will make it 0? Substitute S equal to 3, it will make it 0. Alright. General response. I think this most of you all should have gotten this. If G of S is that, what is C of S? R of S into G of S, right? And this would be, what is R of S here? Does it tell you what R of S is?
Oh, quick.
It says there. Look at that. It says unit step input.
Yeah.
Okay. So your simply this would be S plus 3, S plus 2, S plus 4. Okay. So your C of T would be what? I'm asking you a very general response. So this can be written as A over S plus B over S plus 2
plus C.
C over S plus 4. Okay. So this will be
A
A plus
B
B e to the power of minus
-2.
2t plus C e to the power of minus 4t. That's all. I just needed this, and you don't even need to do all of this. This one line is very clear. If it is unit step, that is how it should come. Okay. Fifth one. So I will do it for this one. Okay. All you have to do is, this is a pole zero plot. Okay. Some of you have given me the response plot. I didn't ask for the response plot. And again, pole zero plots, response plots are very clearly discussed in class. Here, what is this? J omega, this is sigma. And all you have to do is,
I got here late. I couldn't get it.
you have, this is -1, -2, -3, -4.
No, so I have a question.
Yeah.
For the complex and imaginary or complex, can we just use for the test? We can just use like Wolfram Alpha or something to calculate that. Or you want us to go?
Sure, yeah,
Okay.
you can do that. You can use the
How would
calculation.
we can use the computer?
So here you have to just do this, okay? X is for poles,
Circle for zeros.
O for 0. Or circle 0 for 0. That's all. Sixth one was very simple.
I had a question on something. You gonna let us have equation sheets for like TR and TS? And,
Yeah, you can have all those.
okay.
You don't
want us
have to
you want us
memorize
write
any of
something?
them.
Do it
I
for
won't
us?
give you the textbook, but you don't have to memorize any formulas.
Okay. You want us to write a formula sheet or something?
Yeah, you can do a formula sheet. Okay. So sixth one, all the formulas were very simple. Time constant is what? 1 1 over A, right? It is 1 over, here it is 50, right? Rise time is what?
What did you say was X's and what did you say was O? For
X are poles
which one? X on poles?
for this one.
No, for number 5.
That's what we are doing for poles for this, okay? What are the poles? -2 and -4, right? So -2 and -4. Don't take notes. That's the reason I don't want you to take.
What does X equal and O equal? That's what I'm trying to say. You said X is poles and O is zeros.
Right. So what is the 0? What is the value of 0?
It would be positive 3.
Minus 3.
Negative 3.
-3.
Mm.
That is how you represent it.
Okay.
-2, right? You see here. -2, -4.
Mm.
-2, -. You mark it. Just that's all. Okay. So what was TR? I think it was 4 over A. Is that correct?
Did you
The other way, right? I think. Yeah.
Oh, you said 8. I was gonna say 4 over 50, but you said 8.
Yeah. A is what here?
That's 50, right?
50. Yeah. So it is 4 over 50.
Uh-huh.
0.08. Right. This is
2.2. I don't know if that is.
This is 0.0.
I got your unit started. So.
Hmm?
You got
Seconds, yeah, all of them. Seventh one was first, second, 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 right?
Oh, really?
That's all it was.
You gave me an X.
Hmm?
You gave
First
me
order, second order, second order, second order. That's all.
first order, second order.
What's another question?
You gave you marked me off there.
Oh.
I'm not sure. Oh, that one.
No, you got that one right, bro.
Oh, you got -2. Yeah, my bad. Maybe you was talking about something else.
Yeah, that's probably something. I'll look at it. All right.
What's another question? Are you only gonna give us a first order differential equation when solving for TC, TS, and TR?
Not differential equation, transfer function.
Yeah, transfer function. Are you only gonna give us a first
Yes,
order?
you might get a first order system as well.
Yeah, I'm saying like just like this one, or because I mean homework was just first order.
The
I'm saying
homework
you-
was both first order and second order.
Okay. Is that in the later then? So I done. I think I just did the optional ones. I think
It's
it was just like this one. It was just like S plus 50 or S plus 20 or S plus 5 right here.
must have given you check again. You have a copy?
Yeah.
We'll do that. Just give me a second. Okay. So that's all.
I mean, you gave us the formulas for it. I'm just
Right. You can do the first order and the second order formulas. You can write it down. Okay.
The first order and second order formulas. What is that?
Essentially, these formulas. This is the first order. There are second order formulas as well. Right?
Oh, okay. That only applies to first order.
Yeah.
Okay.
Eighth one. How will you do this?
Because I was low key wondering, like, what about when you have a bunch of roots, more than one root? And, like, I was wondering, like, what happens when you have more than one root? You can't just
use a different set.
yeah. And then he's telling me that's what he's telling me. I realize that now. Cool.
Eighth one.
You just plotted it.
You just have to plot. You have to just do this again. Okay.
I messed with number 10. I thought you just wanted.
So the first one, I think you have to do it for the first one as well, right?
What? The plot?
Hmm.
You talking about this?
No. Seventh one. Did you do it for the first one? A?
What are you talking about for number 10? Or number 2?
Oh yeah, you didn't.
Yeah, I just forgot. I thought you were
Sure.
talking about number 9. I just forgot.
The eighth one is simple, okay, guys? What is the first one?
Just put an X on -5. On the X axis.
Just do this. You'll get. Okay, something. See, the thing is, I think you're not reading. It's very very simple, and I think you're cheating on the videos. I just saw the summary of how much you guys have watched. It's barely 5-10 minutes per person, and everybody has commented.
They have that function on YouTube? I don't think they have that.
There is a function. If you subscribe, if I have this thing, I can show you. If you pay them, I pay them to get these statistics.
Oh,
One
yeah,
chapter you're not doing, and you're going to only get whatever if you watch only 5 minutes of the video, you're going to get 5 out of 40. That's your assignment. How much you're going to get?
I noticed something. I actually decided to look into the book, and it was pretty easy to understand.
It is pretty easy. I mean,
so it was like you don't even have to watch a video.
you don't have to make. It's very very simple. And this is, so it is -2, -3, right? This is minus plus j root 6. This is minus j root.
Which one is that one for? That's C.
Yeah.
So now we leave it to the professionals.
I'm sorry, I can't stop.
This is -3 plus
2.64. How do you determine if it's going to be on the y-axis? How do you determine if it's going to be on the y-axis?
What do you mean?
So if
Tell me.
It's based on if you have a real and distinct, real and repeated, complex or imaginary.
This is first order.
Yeah.
Real and distinct.
that makes sense.
Imaginary. Complex. Real and repeated.
But you just
Tell me, what is the issue? I mean, this is really easy. What is happening?
I didn't study.
Julian?
I didn't even know what the test was going to be about. I just learned while I was taking the test.
Bakari? Mohammed? You're not going to pass the course. What is happening? You're not watching the video. You're not. I have done this 100 times in class. What is so difficult here? Is it difficult?
I mean, the book didn't explain how to plot, and I didn't know how to plot real or poles, so that was the issue right there.
The book did not explain?
No, not really.
It did.
Well, it didn't really.
I mean, when you don't know how to plot poles or zeros, you don't know what you're looking for. That's the point I'm making. So, I mean, it happened. I can't take it back.
It's not that it's not that you don't know. It's that you're not trying enough. See, did you really watch the video? Be honest. I have your record.
I mean, I had the video playing while I was trying to do some other work.
That does not work.
I mean, you asked the truth. I mean,
See, you see, that's what I'm saying. If you what is happening here is this has been done 3 times, guys, in class. This is the 4th time I'm doing this for you. I cannot keep repeating and you not respond. You not responding. You will fail the course. This is, I mean, I showed you this in class. Now, what is for example, even some of you have missed this. Now, let me first finish this. So ninth one, it's simple, right? This is what? The first, there is no this thing for, what is this? This is the first order. This is over damped, undamped, underdamped, and critically damped. And the 10th one is, these are in your textbook. If you just open to the right page, you can just copy and get your points, 10 points, okay?
Oh. I got this
If you just open your textbook to the right page, you're going to get this. Is it so difficult to open the page, textbook to the right page? Show me that.
So the midterm is just on chapter 4,
And there will be one problem on state space modeling because you guys have not done good on the state space
that's the one
modeling.
with the springs and dampers.
Yes, but state space modeling, okay?
Oh, with the Z1, Z2.
Right.
That's still just.
If you open the page,
Oh, tough.
You go over a problem with that?
Hmm?
You go over another problem with that?
no, we are not going to go that back. Have you done the assignment?
Some of the homework that we did?
Hmm?
Yeah, we had to do the homework. What are you talking about? There's a new assignment?
Right.
No.
Why not?
Boy, there's a lot going on.
But you're not performing in any way. See, I understand what is happening is, I'm looking at even your satellite design and comparing this. You're not even giving there, you're not giving there. You're not submitted your lab reports, many of you all.
That's not me. I turned all my satellite
No, I'm saying, I'm not pointing at you, but I'm saying,
You were talking to me, then you made that statement. So I'm just clearing that out right now. It's not me.
I'm not talking to individuals.
Okay, just making it clear.
Okay. You're saying there's a lot, but you're not delivering on any front. So what is happening?
Real life. People still got personal problems and family problems going on.
But you have chosen to do this, Julian.
I mean, I know. I'm just telling you what's going on, Dr. Sunday. That's all.
But so are you going to compromise this?
I mean, now I gotta graduate.
Huh?
I gotta graduate.
So how are you going to graduate? See, it's a try to understand. This is a practical problem. I'm not saying if you don't do it, I'm just telling you the consequences. I'm making you aware of the consequences so that you don't fail the course. And I understand how difficult it is. But you are not understanding what is the consequences. You're not giving enough weightage to the consequence. I am giving more weightage because I know you guys have to stay another year to complete if you fail this one course. Only this chapter can be done in one lecture. I have done 4 or 5 lectures, I have given you video lectures, I have given you assignments, there's a quiz, there's a midterm. And you have not done the big worry again is the first test has been really bad. The average is really bad. The second highest score, only one person is passing in the first test. Only one person is passing. So what is happening? it doesn't seem like you're working it. You're not watching videos, you're not doing assignments. We agreed to do the assignments, to use your spring break to catch up on this. And when I said exam yesterday, you were all wondering when was it communicated? When was the exam email communicated to you? Do any of you remember?
Say again?
Exam email, when was it given to you? When was the exam email sent to you?
The email that had told us to do the homework. I remember seeing that like Sunday, but I don't know when you emailed it. Like,
Well, the reason why I was confused though, son, because when we initially set up tests for this class, we put test 2 on the 26th of March.
That is test 2, but this is midterm.
You're kind of test 2 midterm different. Okay.
Yeah. So midterm was actually, when was the midterm? I did not give you the midterm in the midterm schedule.
Yeah, you didn't give us a midterm day. Yeah, I would have wrote it down.
So midterm was Wednesday and Thursday before the spring break. I gave you this so that this can add to your score, and I specifically mentioned in the email, it'll add to your score, and you'll come back and give the midterm.
So, all of this stuff, does it extend the knowledge we need to have to finish the homework?
Yeah, homework is very, very simple.
It's
If
all
you
about
had
this.
attempted it, you know how.
No, I was finishing chapter 4 because I just decided to read it, but I was just making sure that the homework didn't go past all of this.
It's not that simple. This is a quiz, so you have to do some amount of solving. But it is all formulas and just using a calculator and giving something.
For you're not gonna ask us something like this in the test where we have to figure out this, because I just use Wolfram Alpha for this. Because I mean, that would take. I mean, you can do it like this, but I'm just saying when we do this, you're not gonna ask something like that on the test, or you're not gonna expect us to write it in that form, right? Like this right here.
No, you just have to find the roots. So the quadratic equation, solution to the quadratic equation.
Okay. So you don't want us.
No, that it will not be like that.
It won't.
Yeah, that I won't ask you.
Okay. Because the book, when this is how the book did, and that's why I was kind of confused.
Don't worry, I won't take you that far.
So I don't ask the same question. Yeah, I was gonna ask you.
You would?
About, you know how they turned this, they used the tan, the
All right.
coefficient over the second.
We'll just move on with the next chapter, okay?
Where they did the square root of the coefficient, like the 2 on squared and the square root.
I have made you aware of the consequences. So many of you are still far behind, and I'm trying to. It's my honest intent to push you.
So you're not gonna ask us for like the general equation.
Just do chapter 4.
Yeah, that's it. Chapter 4.
I won't ask you to give me. I may ask you something like, what is the general response?
Okay.
Yeah, but that's
When that is a general
the general
response.
response. So we have to that's the general response.
You can general response is.
So you want to do the
You don't have to
inverse
solve
tan.
for that.
No.
If you
have-
recognize, it's recognizing what the roots are.
Uh-huh.
If the roots are.
So you don't want us to write what that is that feet? 5? You don't want us to write what 5 is? Feet 5 4.
No. Look at. I'll tell you what I'm going to expect. Okay, it's. I will give you the table again. All right. The table is based on what is the roots, right? Can you find the roots?
Yeah.
Okay. Finding the roots, everybody can do, right? You don't have to find the coefficients, the partial fraction expansion coefficient, but you will need to find the roots.
What table are you talking about? What table are you talking about?
Essentially, what you're trying to do is table 2.2, the Laplace transform.
Oh,
Okay. All you're trying to do here is, once you know the roots, you're doing the inverse Laplace transform.
So it shows that for complex numbers?
Yes, it
Okay,
shows that.
cool.
That's all it's going to be. Okay. Table 2.1 and table 2.
That's on the book. That's
Yeah.
book.
And I'll give you those tables. And you can bring your own tables if you're not comfortable. And I allowed you to use the tables last time. All right.
Are you gonna ask us to like? You know how they, on the book they're saying that the roots determine the natural response and all that good stuff.
Right.
You want us to point that out? Are you gonna ask us to point that out? at any point?
Yeah, that should be known to you. And we have discussed that as well.
I was saying, you know, the book is like the roots of the system. Yeah, denominator.
Close to zero, so you
That they determine the natural response. But how you doing?
All right. So I'm going to quickly cover stability. Okay.
I think we do.
Alright, is that a
Do this Friday, next Friday.
We have already talked about this. All right. I'm not going to expect you to understand. So, how do you define stability? When is a system stable? Until now, what have you learned about stability?
Stability is the initial tendency of the system to do something when it's disturbed from equilibrium.
So, I'm going to.
That's really what it is.
A system is stable if the natural response for
Listen, you gotta give it steady.
yeah, I guess that's real.
LTI systems
What's our injury?
the natural response approaches
Good way.
0 as time approaches infinity. Okay, and we have talked about this. So here, this itself will tell you. If I look at example, let's look at this, right?
That's my pencil, bro.
So go back and look at your look at problem number 8 or equation 7 in your quiz. Look at quiz equation 7. Okay.
What?
Or sorry, not equation 7. Problem number 7. Okay. I think 7, right? Yeah. 7. Those are systems, right?
Yes.
Now, which of those are stable?
What's wrong with this? Why don't you know?
Torius,
Yeah, he needed a pencil about this.
which of those systems in 7 are stable?
Stable?
Hmm.
The first order? Is it the first order?
Now, so there are 5 systems there, right?
Yes.
1, 2, 3, 4, 5. Which of them are stable?
They approach 0
Hmm.
as time goes to infinity.
Tell me first is stable, second is stable, third is stable, fourth is stable, fifth is stable. That way.
I think B is stable. I think that's the only one because they all go to 1 though.
They are all stable.
They're all stable, but they're all going to.
So if it's if it's unstable, does it always oscillate and never?
It
makes
won't
zero?
oscillate. It will. The
Never get to
unstable system. Try to understand, and that's what I was trying to get you to do yesterday.
Mm-hmm.
If you look at this response of an unstable system, and if this is, it will look like this. Okay.
It looks like it's oscillating.
No, it will increase. The oscillations increase.
Oh, that's negative stability.
That's not that's instable.
That's chaos.
That's not negative stability. That's just unstable. We don't discuss this system. Do you understand?
Okay.
Oscillations are there.
Mhm.
A system can be oscillating and still be stable.
Yeah. Okay. But that just gets worse.
It gets worse. It's exponentially not going to zero. As time approaches zero, as time approaches infinity, the natural response goes to zero. So for example, let's look at this. You have this system, right? We talked about okay. What is C of S for a unit step input? It will be if R of S is 1 over S is S plus 3 divided by S into S plus 2, S plus 4, right? This is the system, this is the unit step response. Got it? And this is how you will split it. We talked about this as well. What is this?
Partial fraction. Oh, those are the roots. What
Those
partial-
are the natural responses. Okay, never mind.
Oh, forced response and natural
Yes.
response.
This is forced response. This is natural response.
No, you didn't.
That's not response.
Okay. If you write this, if you write the time response, this is frequency response, right? This is time response. It will be got it?
Yes.
When time goes to zero, what is this? So here, can I still say this is what?
Natural.
Natural response. Okay.
You're saying when time goes to infinity, or you said zero? But you
Yeah.
Time goes to, this is force, right?
Yeah, that approaches zero. Natural response approaches zero.
Right. So when this becomes time becomes infinity, this will be A, right?
A constant. Yeah.
This will not change.
Yeah, it's gonna stay. Yeah.
There is no t variable here. This will be
Zero.
b e to the power of minus infinity plus c e to the power of minus infinity. You got it?
Mhm.
This will be
Be over infinity or something.
b over infinity, which is 0, right? Plus c over infinity, which is 0. What this translates to is, as long as the poles are in the left half plane,
That's stable.
the system is stable. Does that make sense?
I don't know.
So the poles here are -2 and -4,
Mhm.
right? As long as the poles are in the left half plane. Got it? J omega. And this is. And here if you look at, where are the poles for this? For all these systems. They are all in the left half plane. Do you see it?
Yeah.
This left half, this left half. Here what is it? It's on the, what is this system?
That is unstable because it's on the line.
It's marginally stable. It is neither stable nor unstable.
Okay.
Does that make sense? If the roots are on the right hand side, the system is
What does that do?
unstable. It will do that.
I'm saying, like, what is that? The marginally unstable.
Marginally stable will be just, it will not be neither be unstable nor unstable. Stable.
Oh, so it doesn't get
So-
worse. It doesn't get better.
Yes.
So would you say it just oscillate evenly?
Yes, that's what the response you're looking at. That's what you did. It just does the same thing. Okay. This is the same,
Neutral.
That's cool.
and that's what your response, your plots are showing.
So an imaginary root can still be stable.
Marginally stable. Marginally stable it is. Okay, so this is imaginary. Yes, you're right. This is imaginary roots, right? Roots here, poles. You have to always say poles, okay? Because roots can mean numerator as well, right? Only the poles have, so you have to understand, only poles can determine stability. If the 0 is on the right half plane, it doesn't matter. System might still be stable. Only the poles have to be on the left half plane. Because you see, these values, right? These values directly correlate to
These roots. I mean the roots. Sheesh.
okay, so this 3 does not necessarily come. It only amplifies. It will come into B and C. It will not may affect the stability. So here you are looking at stable, stable, marginally stable, stable, stable. Try to remember the statement. If it is unstable, we cannot control. There is no automatic control involved in that. If this root, if I had this root as minus, okay, this will become plus. This will become plus. This will become infinity. This system is not controllable. So the roots, where will this root be? Where will this pole be? On the right half plane. So this system is unstable. We don't talk about control. For control purposes, we don't talk about unstable systems. Okay, so this is your stability, and the Routh-Hurwitz criteria is.
You still talking about marginally stable systems?
We can talk about marginally stable, but those also kind of out of this thing. Okay. In the videos I assigned you,
That's not what it says, right?
I asked you to do this, right?
Yeah.
When is this useful? Okay. So back in the days, this is something you should try to do. But I'm not going to ask this for exam or anything. Okay? This is it is just for your interest. If you want to do it, I will appreciate if you can do it. If not, that's fine. Because it's not relevant anymore. Okay? It's not relevant in the sense it's not necessary anymore. With the computers, for example, think about this.
What's not relevant? What's not relevant?
That would be the route table.
The class.
It's called what?
If you have a system like this, right?
It's not quite right.
How do you define stability for this?
Figure out the
Would be
roots.
based off of
You figure out the roots and
Shouldn't do all that.
huh? How do you determine the stability of this?
The roots and the time function. The CT.
You just need the
Stability, I
roots.
just told you what is the
All
stability
you need is
criteria.
the roots to find the natural roots ones.
Do you need the roots or do you need what? Poles, right?
Oh, pull.
poles and zeros.
You don't need
Or
zeros.
no, you just poles. So you would
What? The roots
Yeah.
of the denominator.
Roots of the denominator. And then what would you do with the roots of the denominator?
You just use it to make the general natural response. Like,
Stability.
well, you get to find if they're on the left or right side.
Exactly.
Okay.
That's all you need to do. Okay. Can you do this in a calculator?
no.
Yes.
Very
Wolfram.
fancy one.
You need
You
really
can.
big-
Can you do this in a computer?
Yes.
Yes.
So you can do this in a computer, right?
Uh-huh.
Back in the days, there were no computers. So route table was introduced to figure out the stability.
Alright, what kind of
Okay. So you construct the route table and you apply the criteria suggested by that. But what you're going to do is, how many roots will this denominator have?
Roots.
Is that a 6 there? 7. Sheesh.
Not 8. Or, no, sorry, 7.
7, right? All 7 have to be in this plane. Does that make sense? For the system to be stable. You got it? Regardless of how many, what is the order of this system?
7th order.
7th order, right? So there are 7 roots, and you can look at practical systems can be sometimes hundreds of orders, right? That's when it becomes difficult to find the roots of all that. It's a very tedious job to find the roots by hand. So Rout and Hurwitz developed this nice technique where you could do a nice table, and from how you develop the table, you can figure out if the system is stable or not. Okay, it's up to you whether you want to do that or not. I won't ask that for exam, but
Did it take a long time to do?
it is interesting. I have given you. It's a really nice technique. I love the route, constructing the route table.
Right, like a route? It's called
Rout, yeah, Rout and Hurwitz. So
Oh,
Rout
that's
is
right,
the one who started it, and they developed the criteria based on the table. Right. So but I need you to remember this. If the poles of a system, what the statement means is the system is stable if the natural response. What that translates to is the poles have to be on the left half plane of this is called the complex plane or the S plane. Always the poles have to be on the left hand side. Got it? If they are on the right hand side, the system is unstable. Then we don't talk about controls. Alright? I need you to understand this for going forward. Alright?
Will we be doing the Roth?
No, we won't be doing the route in class.
Okay.
I have assigned you videos. You can check the videos and learn it for yourself if you want to. Alright? Any questions?
So you uploaded assignments on Blackboard for
Yes, I have uploaded it more than a week ago. Please take a look at it.
You need to
Yeah, I need to.